Hello everyone, we are Team She3 from Kumaraguru College of Technology. We present MDAD, Multi-Domain Anomaly Detection and Intent Prediction Engine, an AI-powered defense intelligence system designed to detect hidden threats early. The challenge it addresses lies in modern defense operation. Defense systems face gray zone threats, weak, ambiguous signals from physical sensors, cyber networks, and human intelligence. Individually, the signals appear harmless, but together, they can indicate a coordinated attack. Manual analysis leads to alert fatigue, delayed decision, and situational awareness gaps. This is exactly where MDAD makes a difference. MDAD is an AI driven threat fusion platform that automatically correlates weak signals across all domains. Using Bayesian inference, it converts low confidence alerts into high confidence threat prediction, predicts adversary intents, and enables proactive response instead of reaction. This allows commanders to act early with clarity and confidence.
This is the flowchart. The first step starts with the data ingestion. The MDAT system starts with data ingestion from three independent intelligent domains. All this raw data collected is unstructured and incompatible. So the next step is data normalization, which starts with the parser. Each parser extracts only the relevant intelligent signals. For example, if it's spatial normalization, it converts everything to common latitude and longitude, whereas in temporal normalization, it aligns events into common time and windows. After this step, all data speaks the same language in terms of time, location, and confidence. Then the next step is a Bayesian fusion engine. This is the core intelligent engine of MDAD. Spatial correlation or events happening near each other. In temporal correlation, are they happening close in time? In semantic correlation, do they represent related threat types? These correlations are fed into the threat score calculation, which uses a Bayesian logic. Even if each signal is weak on its own, when multiple independent signals align in time, space, and meaning, the system produces a high confidence threat score. In the high confidence threat score, only if the confidence crosses a threshold does the system proceed further. This prevents the false alarms. Then the next step is a intent prediction. Once a high confidence threat is identified, MDAD moves beyond detection to intent prediction with different recognition patterns. Based on these patterns, MDAD generates a predicted intent output, such as pre-attack reconnaissance or intrusion preparation. Then the recommendation generation will come, which recommends actions based on the predicted intent. Fifth step is the visualization output. All the insights are then presented through intuitive visual dashboards, for example, using charts, map rendering, or alert dashboards. So finally, MDAT produces actionable intelligence, not raw alerts. So commanders can now confidently decide whether to ignore, monitor, or act based on the unified confidence driven threat assessment. Then the next one is the architecture. In that, there is a tech stack which consists of backend, frontend, and the database.
This is our project demo, the MDAD platform, multi-domain anomaly detection platform. Here you can see the live map, which shows the overall geospatial view, like how many signals and how many threat clusters are there. These are color coded. So blue for physical signals, red for cyber signals, and green for human signals. And here there are threat clusters. So threats are clustered based on the location where they are detected and when they are detected, the time frame, and what are the signals and what is the predicted intent, and it is low confidence or high confidence. If it is a high confidence threat cluster, then it will go to the alert feed, and then comes the dashboard. So dashboard is the command center with the charts like the threat timeline chart, pie chart, and the confidence histogram, etc. And there is also key metric cards like number of active threats and confidence percentage, and what are the signals processed and X domain correlations. And then the important part is this alert feed. So the high priority threats, the threats that are having more than 70% confidence will be shown here, so that we can take actions. And then the header controls. So the live toggle, this live toggle we can pass, so we can turn on and off the real-time signal generation. This is only for the prototype. And then the recalculate and download, we can download the current threat report as JSON file, and then the settings icon. So here we adjust the alert threshold, spatial radius, and so on. Up next, the market potential. Our primary market is defense and national security. The US C4ISR budget exceeds $15 billion annually, and MDAD fits directly into that mission. We serve special operations, forward bases, and cyber command with a unique advantage. We predict intent across physical, cyber, and human domains. That same capability scales to critical infrastructure, border security, and major events. That is, anywhere fragmented threats must become actionable intelligence.